Hello everyone, and welcome to the Game Engine programming series where we write a game engine from scratch. We have spent the last couple of episodes setting up the asset pipeline and started with the geometry asset. We created the content tools to generate and process meshes and also made the control in the editor to visualize the generated geometry. The last remaining part of the pipeline is the ability to save the geometry to asset files so we can eventually load them in the engine, and that's the subject of this video. Okay, let's start by doing a couple of small fixes, as we often do in this series. The first one that I'd like to do is the fact that when I press enter here, while this project is selected, the focus is lost and I have to either select it again or just press open. And that's because of the fact that create project control here also is enabled. And if you remember, we disabled these controls when we switch between them. As you can see here, these items go gray because the whole view is disabled. But the first time that I open this application, create project is not disabled. And therefore the focus shifts to that one for some reason. I don't know why, but I can fix it. Let's open project browser dialog. And where we have these two controls, I can simply say is enabled false. And now when I press enter, it will open the project. The next fix that I would like to do is to format this angle a bit so it has more room within this border, and also the title is wrong. And fortunately, I can just do the hot reload thing so I don't have to restart the application. In primitive mesh dialog, I can go here in this part where we set the smoothing angle. Here I can change this to smoothing angle. And the spacing around this stock panel should be bigger, like this, because I'm using this for the other elements as well. And now you can see it's got a bit more room and the title's changed. And the last one that I would like to fix is this. The size of the sphere is bound to X component in all directions, and the other two don't work. To fix that, we go to update primitive in mesh dialog, and here you can see that I'm using X scalar box for all three directions, which is wrong. And now you can see that I can change the size in 3 different directions, which is correct. Okay, now we can start doing the thing that we wanted to do today, which is saving this object or any object that's generated in this control or imported by using the geometry asset pipeline. And well, we already have the save button, which doesn't do anything yet. So I'm going to add the functionality to save the object when we press this button. First, add an event handler for that. Here you can see that there is no event handler for clicking the button. And let's add this for the plane as well. And I hit F12 to generate this function. First, we need a location for this object to be saved. And to ask the user to give us a location, I'll just use Windows SaveFileDialog. And to use this, we need to add the Microsoft.win32 namespace. When we create an instance of this dialog window, I can set an initial directory for it. And I also can give it a filter that will show me only a certain type of file. And the filter that I would like to use is to show me the files that have a certain extension. And the asset extension for Primal Engine is .asset. So with this filter, I'm only shown the asset files and nothing else. And for initial directory, I would like to ask the current project that we have for a location for the content. So you can see that we have the full path and solution path and those kind of things, but we don't have a path for the content. So let's add that to the project class. Here we have a solution path, and I'll just add another one for the content. And to open this SaveFileDialog, we of course need to call showDialog. And when the user clicks the save button in the dialog, then it will return true, and then we can write the save logic here. Here I click save, and then you can see that the save file dialog is opened, and we are in the content folder for this game project. Later, I'm going to write our own content browser to save files because I would like to restrict the user to stay within this content because we have no way of tracking where you save the assets. And when we constrain the user to just use this folder, you can, of course, create subfolders within it, but then we know that all the assets that are used in a game project will be within this folder. And that makes things a lot easier to track. Now that we have this dialog window open, we can click save. And of course, we need to give it a file name. And if I click save, then nothing happens because there is nothing to save the object yet. So let's continue and write that code. First, I would like to check that the returned file name from this save file dialog is valid. Then I'm going to get the asset that we have here in the data context. Check if it's not null. And finally, I'll call asset save with the file name that we got from the user. Now, of course, we don't have a save method in the asset base class. So we need to add an abstract method to this base class so that every class that's going to inherit from asset also has to implement a save method. Here in asset class, let's add a new method, which is an abstract method. Here we have a prototype for a save method that takes a file location to save the asset, and it gives a list of file names. Because saving an asset class can result in multiple files being saved to the content location. For example, if you have multiple meshes within the geometry asset class, then it will save those meshes to different files. And also when we import certain kinds of files that have embedded resources like textures in them, then those files obviously will be saved as well. So that's why the return type of the save method is a list of file paths that have been saved. Okay, before implementing this though, I'd like to add a couple of properties that we need for each type of asset. We already have one here, it's the type. And the next one that I'd like to add here is an icon for the asset that we are going to save. So when we have our own content browser, we will be able to read those icons and show them to the user. The icon is just an array of bytes, or a buffer, which contains the raw data for an image. Next, I'd like to also have the source path for an imported file. When we are going to import a texture or a geometry from a 3D file, I would like to save the location of the source with the asset, so we always know where it came from. Because multiple assets can have the same name, I would like to have a property here by which we can differentiate between different assets. And a global unique identifier is the right property to use here, so I'm going to add it now. And I'll give it just a new GUID every time we instantiate a class that derives from the asset class. Next is the import time. When we create or import an asset, then I'd like to remember when it was. So when the source file updates, then we can compare the date of the source file and the date of the importing. So if the source file is newer, we can notify the user that a newer version is available if needed. And the last property that I'd like to add for now is a hash. And a hash is useful when I want to compare different assets that might come from the same source. So that makes it easier to compare. And if they are the same, we can notify the user that they are having a duplicate resource here and they might want to get rid of one of them. And the hash is also just an array of bytes. Now when we save an asset, we want to save these properties as well. And rather than writing these in each type of asset class, I'll just add a function here that each class that has inherited from this asset class can call to kind of write a header to their asset file. We are going to use a binary writer to write our asset files, and when a file is saving, then we can use that binary writer and pass it to this function so that we can save these properties. Because we know that these properties are the first things that need to be saved in a file, we explicitly set the writer position to the start of the file. And then we can start writing to the file. The first property that I'd like to write to the file is the type of this asset. Next one is the GUID. For the GUID, we need to write the length of the byte array that we get by calling this function first, so that we can read it back later. Next, I'll save the import date. We might want to use a different date for this, like the same date as the source file of this asset. But for now, because we are not using a source file, I'm just using the current time and date. And then I convert it to binary, and then I can write that as a long integer to the file. I would like the asset hash to be optional, so not all assets will have a hash. If there is a hash and it has a length larger than 0, then I write the length of the hash and save it. And otherwise, I just write 0, so we know that there will be no hash information on that location. Then I would like to save the source path. Now that we are generating our geometry exclusively by using this primitive mesh dialog, we of course don't have a save path, and therefore I just write an empty string in there. And when we import our assets, then there will be a source path, and then we just write it to the file as a string. And the last one is the icon. Okay, that will save all these properties that we have here and the information about the asset that we have in common between all types of assets. And next we will have to implement this save method for geometry class. Let's go to geometry, and then we can see here already that we have an error because we haven't implemented the save function. Control dot and implement abstract class, and it will add it for me. Okay, before saving, we need to check if we have any data available in the first place. Remember that our objects or our 3D meshes are located in this lot groups list, which is a list of lot groups. A lot group represents an object that needs to be saved in a different file. So when we have more than one object imported from a 3D file, then we need to save multiple files. And we need to return a list of files. So let's create a list of saved files here. And if we don't have any objects, we just return an empty list. Next, we want to know where the user wants to save the files. This function will get the folder where this file resides. And I also get the file name without its extension. So when we want to generate names, if we want to save multiple files, we can use the file name. And whenever we are working with files, we put everything in a try catch block. And there is a code snippet for that as well, included in Visual Studio. Just type try and then hit tab twice, and it will fill in try catch block. And if everything goes okay, we return the list of saved files. Here in this try block, we go through every lot group and save them to a file one by one. First, we make sure that there is actually information contained in this lot group, in this object. Here, for each file that we want to save, we need to generate a file name based on the path and the file name that we got here. And we add the name of the most detailed LOD of this mesh to the end of that file. Otherwise, multiple files would end up having the same name, and that's not what we want. Next, I'd like to add a constant in our asset base class that will contain the default asset file extension for this engine. And as I discussed before, I would like to use .asset for the asset extension. So going back to asset class, I can add a constant that says that the default extension is .asset. Now, because you are free to name your mesh anything you want, that means that the name of a mesh could contain invalid characters for a file name. And therefore, we need a file name sanitizer. And I'm going to write that as a helper function in content helper class. Here, the only thing I need to do is to look up if this v has any invalid characters in it and just replace it by an underscore. Here I'll go through the list of invalid path characters and replace them with an underscore if there is any in this path. And then I'll do the same for the file name. And when we are done, I simply add the file name back to the path and return it as the full path of this file. Now, because we are possibly saving different files, we need to generate new GUIDs for each file that we are saving. So we can't use the default one that was constructed in the base class. And then I need some space to save my data in. The first properties that we save are the name of this object and the number of submeshes that are contained in this object. Remember that a mesh can have multiple LODs, and those LODs can have multiple submeshes as well. And because we are having multiple meshes, we will get multiple hashes, and I'll combine those hashes together so we get one hash for all the meshes that are contained in this object. Here we have a method that will write the data from a load in a binary format, and also it will give us back a hash, and we can add that hash to the list of hashes so that we can combine them later. Okay, let's implement this function. Now we are trying to just write a lot from the list of LODs in the object. So one LOD can have multiple meshes, and therefore we need another for loop here as well. But first, we just write the name of this LOD and its threshold, from which distance it should be switched to another LOD. And before we go through all the meshes, we need to save the number of those meshes. And I'll remember what the position is in the file at this point. And I need this because I just want to calculate a hash for the mesh data only and not for the names of the LODs and those kind of things. Here we save everything that we need to know about a mesh, like the vertex size and the number of vertices and the vertex buffer, and the same for indices. And I'd like to only calculate a hash for this data, because if anything is different, then that means that our mesh is different, and that will reflect in the calculated hash. But we of course can have the same mesh with different names, and that shouldn't matter because still the mesh is a duplicate. This is simply the number of bytes that we have written for all the meshes, and we check here that that size should be larger than 0. To compute the hash, we obviously need a compute hash function that will take the binary data contained within this buffer So this is a function that will return a byte array, and it will take in a buffer and a starting offset, which by default is 0, and a count, which by default is also 0. And I would like to rename the buffer to data. And in .NET we have a cryptography namespace which contains SHA-256 class, among other kind of cryptography classes. And we are going to use that one to create a hash for us. If the user provided a count, then we'll use that one, and otherwise we will take the length of the data. And that's the way we compute a hash for a chunk of binary data. Going back to geometry class, here we also need to give it the correct type, so it's a byte array. And then we are done writing the lot data to the file. And we can go back and continue here in the save method. Now that we wrote all the level of detail objects to the file, we need to combine these hashes and again compute a new hash from those. And the next thing that I would like to do is to generate an icon for the object that we are saving by using its most detailed LOD. The time is up, however, and I'll continue implementing the rest of the save functionality in the next video. Thanks for joining me today, and hopefully I'll see you back on this channel next time. Thanks for watching. If you like this video, please feel free to like and subscribe. If you join me on Patreon, you'll get access to the code on GitHub, so you don't have to type everything over from the video. Plus, there are also other nice goodies and rewards exclusive to my Patreon supporters. Please use the link in the video description to check them out. I hope to see you next time. Until then, take care and happy game engineering!